Hi, welcome to the Math Center. I'm Ravi Menon. On the board here, we have a question we recently discussed in one of our IGCSE maths classes. So I thought I'll share it with you guys out there. The problem involves differentiation. You are given a curve y equals to x squared e to the power of minus x. That's what we see here. And you're told that the tangent to the curve at this point P passes through the origin. So here you have it, the origin, you have the point P. And you're asked to find the x coordinate of P. Okay, there are quite a few ways to solve this problem. Let's just do one of those, okay? Since we are dealing with tangents, we will have to go ahead and perform some differentiation. So let's start with that. So y equals to x squared e to the power of minus x. So we will use the product rule. Let's do that. dy dx equals, write down the first term, differentiate the second, plus, write down the second term, and differentiate the first, we have 2x. So this x squared is what normally people like to call u, okay, the first term, and this is what we like to call v, the second term. So when you clean this up, you can write it down as 2x e to the power of minus x minus x squared e to the power of minus x. I just wrote, let me get that again, okay, because there's a negative here. I didn't want the negative to be in front, so I wrote this term first. So I have 2x e to the power of minus x minus x squared e to the power of minus x. We're done with the differentiation. So let's say we have this point P. Let's call the coordinates k. If you let the x coordinate be k, so the y coordinate will be k squared e to the power of minus k. Okay? If you know the x value, you know the y value. So at P, we are told, right, the tangent at P passes through the origin. So let's go ahead and find the value of the gradient of the tangent. Again, let's find the value of the gradient of the tangent. So at P, okay, gradient of tangent will be equals to 2k e to the power of minus k minus k squared e to the power of minus k. Where do I get that? By plugging in the value of k in my gradient function. So I have 2k e to the power of minus k squared e to the power of minus k. Good. So the gradient of the tangent we have found. Now we are told that this tangent passes through the origin. So we have OP, the line segment OP. So what is the gradient of OP? Let's write it using this notation. The gradient of the line OP, that will be using y2 minus y1 over x2 minus x1. We can write it as k squared e to the power of minus k over k. y2 minus y1. Okay, this is y2. y1 for the origin we know will be 0, because the coordinates of the origin will be, let me write it down here, 0, 0. So we have k squared e to the power of minus k over k. So that's the gradient of the line OP. And that's also the tangent. Okay, that's also the tangent. So we can write, okay, so we can equate both of these. Yeah? So let's write 2k e to the power of minus k squared e to the power of minus k will be equals to k squared e to the power of minus k over k. Okay, so again we are equating these two gradients that we have found. Okay, so I have 2k e to the power minus k squared e to the power minus k. That will be equals to k squared e to the power minus k over k. Okay, now we are almost done. So let's go ahead and cross multiply. We have 2k squared e to the minus k. Okay, bring the k up. 2k squared e to the power minus k. And then I have minus k cubed e to the power minus k equals k squared e to the power minus k. What have I done? Cross multiply. Brought the k up. I have 2k squared e to the power minus k. Okay, and I have k times k squared is k cubed. I have e to the power minus k here, and I have my k squared e to the power minus k there. Now we can get rid of the e to the power minus k. Let's cancel. So I'll have, okay, let's write it here, 2k squared minus k cubed equals to k squared. What have I done? I have cancelled e to the power minus k. Or another way of looking at it is, we have a common term, we can get rid of it. Okay, so let me just draw this lines here. Okay, now we are almost done. So let's bring it up here. Bring the k squared to the left. I have k squared minus k cubed equals to 0. Take out k squared. I have 1 minus k equals to 0. And we know that k is not equals to 0. Therefore, 1 minus k must be equal to 0. Therefore, k equals to 1. And we are done.